in a right angled triangle, and we're using trigonometry. So our first example says find the value of the two angles to one decimal place where needed. So if you look at our triangle here, notice how if you look at it, we've got an angle here and an angle here. Okay, one of the best ways to approach this is by simply redrawing the triangle. So I'm going to quickly just copy and paste my triangle. Okay, I'll change the color too so then we know we're working with this. Alright, and I'm going to do it again over here. Okay, and then what I'm going to do is I'm going to get rid of one angle in each of these triangles. Like this. Now, what this means is that in each triangle, I've only got one angle I'm trying to find. So I'm going to go ahead and label my sides. So I'm going to start with A, O, and H. If I look at this, I've got H and O, so I'm going to be using sine. Okay, so I'm going to go down here, and we're going to go sine, O over H. Okay, substitute in what we do know. Okay, we know O is square root 2, not 3, and it's over 3. Okay, then here we have inverse sine, and then square root 2 over 3. And what we do is we then chuck that in our calculator, and then we're going to get an answer. Okay, so if I go, so remember you have to hit shift or second F or whatever that type of button on your calculator is, sine, and then when you do it, you're going to do square root 2 divided by 3 and put that in brackets. So when you're doing it in your calculator, it should look like this. Okay, and that's how we can do the fraction in our calculator quite easily. So if I then hit equals, I should get 28.1 degrees. So we've done our rounding and we're all good to go. So there we go, we have found our first angle, we've found theta. So now let's go over here and we're going to use the same approach. I'm going to start by labeling. So there's my A, there's my H, and O. I look at this, okay, and I've got A and I've got H. Okay, A and H means cos, so we're going to use cos. Okay, substitute in what you know. Okay, so still got that square root 2 over 3. Except for I'm using the wrong symbol for the angle. I should be using the other symbol. Like that. Okay, now we're good. Okay, so then we've got... Okay, and now we go about that the same way in the calculator, but this time using cos. Okay, so I'm going to hit shift, cos, square root 2, divided by 3. Make sure your bracket's closed at the end. Okay, and we get 61.9 degrees. Okay, now if you look at these, you know you've done it right. If I go 28.1 plus 61.9 equals 90 degrees. If it doesn't equal 90 degrees, check your rounding as there may be an error there. Okay, because if you remember in a triangle there's 180 degrees. Now 90 degrees has been taken up by this here already. That's why I know I've got 90 left. Okay, let's do another one over here. Okay, so we've got this one here. Alright, so we're going to use the same approach this time. I'm going to copy my triangle and I'm going to get rid of one of the angles in each of them. So I've got one angle in each. Okay, so in this one I'm just going to work towards theta, and then this one I'm going to work on the other angle. Okay, so start by labeling your triangles. So we're doing A, H, and O, A, O, and H. Okay, look at each one. Alright, highlight which ones we've got two things on each side. So where I've got my A, I've got a 4. Okay, so if I look at this first one, I'm going to be using cos because I've got A and H. So substitute in your values, which is 4 over 6, inverse cos. Alright, chuck that in your calculator. So inverse cos. And that gives us 48.2 degrees. Okay, so now let's do the same thing on this side, but this time we're using sine. So we're going sine Okay, 4 over 6 again. So you're still using, if you notice, these same numbers on both. And that's fine. Okay, inverse sine. Okay, so inverse sine, 4 divided by 6, should give us 41.8 degrees. Now make sure these add together. So 48.2 plus 41.8 gives us 90 degrees. And we've done it right. So then our other example, I'm going to show you a real quick cheat way to do this instead of working individually. So it says the length of two sides of a right angle triangle are provided. Use this info to find the size of the two interior acute angles and round each to one decimal place. So when it's talking about those two interior acute angles, okay, it's talking about, so if I draw a right angle triangle, it's talking about these two angles down here that are less than 90 degrees. Okay, so in each of these, we're finding those two smaller angles. So what we need to do is we look at our first example, we've got the hypotenuse and the opposite. So since I've got H and O, I'm going to be using sine. So here we're going to start with sine O over H. It's really helpful to write it out as the formula first because it reduces mistakes. So sine, okay, our opposite is 4.5 and our hypotenuse is 6. Then we go inverse sine. Okay, so then we go and put that in our calculator. So inverse sine, 4.5 divided by 6, and that gives us 48.6 degrees. So now what I'm going to do, instead of going through this whole process using cos, because that's what we would use, I'm going to turn around and go, I'm going to go 180, take away the 90 degrees for our right angle corner, take away the angle I just found, so 48.6, and that's going to give me the third angle there. So if I go 180, take 90, 48.6, I get 41.4 degrees. And bam, I've now got both of those acute angles. Okay, so there you go. There's the real quick cheat way. So let's do it again one more time. So this one here, we got the hypotenuse and adjacent. Okay, so if I've got H and A, I'm using cos. Okay, so let's start that. Okay, and then we're going to go 2.9 divided by 8.2. Inverse cos. Like that. And chuck it in your calculator. And we get 69.3 degrees. So then to find my third angle, I'm going to go 180. Take away that 90. And take away my 69.3 degrees I just found. And that's going to give me that last angle. Okay, and that gives us 20.7 degrees as that last angle. And now we've just achieved exactly what the question's asked. So it says use this information to find the two interior acute angles. So if we've got this one here and this one here, we've found those acute angles. Okay, so as long as you've got two angles less than 90 degrees, you've done your job. And it says round each to one decimal place, and we've ticked that off as well. And once you've done that, you've achieved what the question's asked. Thank you for watching.